Hello guys, so in this video we are going to address some question and answer regarding the number system. So in the previous lecture we have seen the set of number systems and then we have taken a simple example for the number system conversions from binary to decimal and decimal to binary, and in this video we will discuss some questions and the corresponding answer for the number system. So let us start with that. Okay, so the questions listed over here are the part of the tutorials that we used to conduct in the uh, course in the current semester, which is called as digital logic design, and this is the tutorial 2. So the first question is to identify the base value. So the question is compute the value of b. Here the b indicates the base for the following case. So here the number is given. Okay, so the number is in, let us say, the decimal. The number is 16 and the corresponding number is given, that 100 with base system b. Okay, now it is said that both numbers are equal. That means the number 16, which is in a decimal, when will be converted into the base system b, that number will correspond to 100. Okay, now we need to identify that in which base system b that number 16 will be converted to 100. So that is the fundamental questions usually asked in a lot of the competitive examinations as well as the university level exams, so that we are going to discuss over here. So the tutorial answer sheet is over here. Okay, so as we know that the number which is given on the left hand side is 16 with base 10. Okay, this number. So we can also write the 16 in base 10 as simply like a 16. Okay, and on the right hand side the number is 100. So as we can know that from decimal, okay, to convert that number into the binary, okay, so that we can do some process. But here what we are doing, that on the right hand side the number is given is 100. That means 1, then 0 and 0, and the base system is given b. Okay, so from any base system to go into the decimal, what we used to do is that we take the individual digit of that numbers, here 0, and we multiply with the base with some power. So the least significant bit, then the power is 0. Then when we move towards the left hand side, we increase the power by 1. So here the 0 is multiplied with base system b with the power 0, b with the power 1, b with the power 2. So that number 1, 0 and 0 is multiplied in this way. Okay, now this becomes a quadratic equation. Okay, so that means we can write this in like a b square plus, now 0 multiplied by anything is 0, 0 multiplied by anything is 0. So ultimately this entire quadratic equation will be simplified to b square. Okay, so that means the 16 is equal to b square. Now as we know that when we take the square root, then on the both sides, then 16 becomes plus and minus 4, and b square will become 4. B square will become b. Okay, so ultimately b will be plus and minus 4. However, as we can know that the number system cannot be in negative. Okay, so that's why we can retain only the positive 4 and we will discard the negative 4. So from this example we can know that we get to know that this 16 in the base 10 is equal to 100 in base b. Then in this case the base b must be a 4. That means the base 4 number system. So that is the simplest way we can solve such kind of exercise. So now let us take a few more examples to understand that how systems work, what is the actually concept. So here the second question is determine the base value, similar to the former question. Okay, so determine the base value of the number system using the following expressions. Okay, so the first expression is given is that 23 plus 44 plus 14 plus 32 is equal to 223. Now it is given that both are equal. That means the left hand side is equal to right hand side. And the question is that here the base system is not given. That means we don't know that 23 is in a decimal or in a base 4 system, base 5 system. Anything is possible because the highest possible number in this 23 is 3. So it is possible that the number 23 is in a base 4. It is possible that it is in a base 5 or so on. Okay. So here anything is possible, but the base system is not given, and it is said that you need to identify the base system. So the benefit over here is that the equation is given. That means both are the equal. So let us see that how we can solve this problem. Okay. So first of all, we will assume that the base will be some variable b. Okay. So when we assume something is a base b number system, then what we can do? We can take the individual number and multiply by that number with base b and some power. Okay, so what we can do, sorry, so here the first number is 23. Okay, now I want to represent that number into some number system, base number system. Okay, so let us say the base is b, so I can write that 2 multiplied by b to the power 1 plus 3 multiplied by b to the power 0. So that will be represented in a base b. Similar like this, 2 b to the power 1 plus 3 multiplied by b to the power 0. So b to the power 0 is ultimately 1. So we can choose not to write that. Similarly, the number 44 can also be written as 4b plus 4. 14 can be written as a b plus 4. And this 32 can be written as a 3b plus 2. And this number 223 can be written as 2b square plus 2b plus 3. Okay, so once you write that expression in this way, you will end up with some equation. Okay, so what is the equation over here? Let us see that here we have only one part with the b square, so we can write the 2b square. Okay, there is, I don't think so there is any other value. Okay, so far no. So 2b square plus 2b, here 2b over here, and we have the 2b plus 4b plus b plus 3b. So total 2 plus 4 is 6, plus 1 is 7, plus 3 is 10. Okay, so 10 b over here and 2b, so ultimately it will be a uh, should be 8b. Okay, so when you will solve this equation, ultimately you will end up with b square minus 4b minus 5 equal to 0. And you will solve this quadratic equation, you will have two values, b is equal to 5 and b is equal to minus 1. Okay, so as we know that the minus is not possible, we cannot have a number system or a base b having a negative value. Okay, so it is not possible, so we will retain that value, the b is equal to 5. That means this entire equation will hold true in a base system, b is equal to 5. So that is what the answer. Now let us discuss the another example that is given as a 41 divided by 3 is equal to 13. Okay, so similarly you can represent that, assume the base system b and represent each and every number in that base b representation. So 41 will be represented as a 4b plus 1, then we can have a 3 as it is, because 3 multiplied by b to the power 0 will be 3 ultimately, and this 13 can be represented as b plus 3. Okay, so here you can have that idea, that is 4b plus 1 divided by 3 is equal to b plus 3. Now you will simply solve this equation, that is 4b plus 1 is equal to 3b plus 9, and ultimately it's the b plus 8. So that means this equation will hold true, that is 41 divided by 3 is equal to 13 will hold true in the base 8 number system. Okay, now the final question over here is the square root of 41 is equal to 5. So in which base system this equation will hold true, that we need to find. So again we will assume that the base system is b. First of all we convert these numbers into the base system b, and then after we will solve the equation. So ultimately my equation will be square root of 4b plus 1 is equal to 5. Okay, so you can see over here that is a square root of 4b plus 1 is equal to 5. You take the square on the both sides. So this means 4b plus 1 on the left hand side is equal to 25. That means 4b is equal to 24, and we will divide this 24 by 4, then b will remain as a 6. That means that equation will hold true when we have the base system b is equal to 6. So that is what the uh, all about the question and answer in the second part. Thank you.